Today we're going to look at logarithms. In the last couple of lessons we've been using exponential equations to solve for powers of x, but sometimes it's not possible to make the bases the same and to solve those kinds of equations, and that's where our logarithms come in handy. So on your calculator there are two buttons that you need to be familiar with. First of all, there's the one that says log, which stands for a log base 10. Now this is base 10 means it's based on our Australian number system where we operate in tens, hundreds, thousands, so it's a very useful log button to have on your calculator. The second one that you have is this one that says ln. The n stands for natural log, and that is a log with a base e. Now the letter e is Euler's number. It is a constant that is used a lot. It is like pi, it's an irrational number, and so it's 2.7 and a whole bunch more decimal places. It's a very special number because the graph of y equals e to the x, the derivative of that graph is also e to the x. So the derivative or the gradient is the exact same as the original function. So that's why this is a very useful letter e to use, and that's why we want to be able to use the natural log button as well. So let's just practice on our calculators using these buttons. So the first one, we want to find out what log base 10 of 5.7 is. So on your calculator you just want to type in the log button. You don't have to type the 10, it knows that that's a base 10, and you just type 5.7 equals, so that's 0.76. Let's just do two decimal places. Okay, then the second one is log with a little base e there. So that's when we use the ln button and we just type in the 2.9. So that's 1.06. Okay, so what does a logarithm do? That's the key question here. To read a logarithm, you'll see it written like this: y equals log base a of x. And what it is trying to do, whatever that base number is where the a is, it's a to the power of what gives you x, which is why this is very easily related to be in exponential form. And we're going to convert between the two things. To do that, we do what's called a sliding base. Okay, so the base here, it's going to slide across to the other side, and it's going to be the base of the y. So it's going to be a to the power of y, which is going to be equal to the x, and that's how we get to this second form here. So question number one is practicing doing just that. We're going to practice our sliding base to put these into logarithmic form. So the 2 that is the base here, we're going to slide it across to the other side. The 5 will stay where it is, and it will become log base 2 of the 32. Okay, that's it. We're not going to solve that any further than there. We just want to practice sliding the base. So let's try the next one. For the base of 5, we're going to slide it to the other side. So the 3 is going to stay there, and it's going to become a log of base 5 of 125. Question 2 is doing the reverse. We have a logarithm here and we want to rewrite it in index form. So we just keep sliding that base. So the logarithm is going to disappear. The 81 stays where it is. The 3 slides across to the other side and becomes the base of the 4. So it's 3 to the power of 4. Then let's try the next one. To change that into index form, we're going to leave the 1 million that's there. The base 10 slides across to the other side to be the base, and it's going to be 10 to the power of 6. Okay, now not every equation that's written as a logarithm needs to be changed into index form. We can actually calculate some of these in our head. Remember, to read a logarithm, it's whatever the base number is, you're trying to find the power that gives you the big number on the end. So you're asking yourself, 2 to the power of what gives 16? So you could be checking that on your calculator if you needed to. You go 2 to the power of, maybe it's 3. No, that's not big enough. It's going to be 2 to the power of 4 gives you the 16. So the answer to that question is 4. 2 to the power of 4 gives 16. So log 2 of 16 is equal to 4. Let's try it again for part B. The logarithm is asking us 10 to the power of what gives 10,000? It's 10 to the power of 4 gives me 10,000. So that logarithm is also equal to 4. On the next page, if we can't determine the logarithm in our head, we need to be able to solve them by changing them into index form. And that's what we're asked to do in question 4. It says solve each logarithmic equation by changing it into index form. So we're back to sliding our bases. So the 5 that is the base here is going to slide across to the other side, and it's going to become 5 to the power of x is equal to, the log disappears and it's just 1/5. Then we've solved these type of equations before. We want to make the bases the same. So they both have 5s there. Let's just rewrite the right hand side. That would be a 5 to the power of 1. If we take it out of fraction form, that would be 5 to the negative 1. Then once the bases are the same, the powers must be equal, so x is going to be equal to -1. Let's practice that again. So we have a logarithm. We're going to slide the base. The 27 comes across to the left-hand side, and it's going to be a power of 1/3. The log disappears, and that's going to be equal to x. Now, x is equal to 27 to the power of 1/3. A power of 1/3 is the same as a cubed root of 27. The cubed root of 27 is 3. Part C. Okay, sliding the base. The base is the x this time, so the 12 is going to stay where it is. The x slides across to the other side, and it becomes a power of -1. Now, a power of -1 can be rewritten to be 1 over x. To solve that equation, I'm going to times the x to the other side. 12x equals 1, and then divide by 12 gives me x equals 1/12. And one more of these. We're going to leave the 9, slide the base to the other side, so it's x to the power of -2. Just like last time, I'm going to take that out of negative power form and put it into a fraction, so 1 over x to a +2, times the x squared across to the other side, so 9x squared equals 1. Then I can divide by 9, and then to get rid of the squared, I want to square root 1 over 9, which would become square root of 1 is 1, square root of 9 is 3, but when you square root, remember that it can be a plus or a minus. Question 5. Solve each index equation by changing it into a log equation. So, sliding the base. The x is going to stay on the left-hand side. The base 10 slides to the other side, and it becomes a log of base 10 of 125. So we use our calculator because it's a log base 10. So that's our log button. And then we just type in 125. And it will tell me what that's equal to many decimal places. Let's just do 3 decimal places. So 2.097 to 3 dp, 3 decimal places. Let's try that again. The x is going to stay on the left-hand side. The base 10 slides across to the other side. Log base 10 of 0.123. And again, base 10 is one that we can do on our calculator. So log of 0.123 is 0.91. Okay, and that's it. You need to work on exercise 8C.